I would connect to the brain by way of the optic nerve. One optic nerve per eye, of course. Now we're going to look at the interior of the eye, and you already have dissected specimens in that pan. I want to tell you what I'm going to do to expose this one like those that you have in the pan. I'm going to make an incision. Now the incision, look at my fingers. It's going to be halfway between my thumb and index finger on top, and it's going to be just big enough for me to insert the point of the scissors in it. If you are doing this yourself, be aware of the fact that there's fluid inside this eyeball, and it may squirt if you press on the eye very firmly. After making that little short incision, then insert the pointed end of your dissecting scissors into that opening, and you're going to cut an incision that completely encircles the eye, kind of like when you crack an eggshell in half. Now I'm not going to make a complete circular incision so that I can leave the two halves together.
You want to cut it? You can just look at one. I would hate for us to get squirted. That'd be kind of.
Alright, now I've got
the
eyeball cut in
half. And why did we get it?
And I'm going to hold the back half together with my index finger, and I'm going to show you the inside of the front half. Alright. What's this black layer of the eye called that we can see in the front half? It's black. It's a dull shade of black. It's not shiny. It's one of three layers that make up the eyeball wall. And this black one is the middle of the three. What's the name? It's on your diagram on page 237. It's called the choroid layer. Everyone see that labeling?
Okay, I got it.
You might mark it as one of the parts you have to know. Now, in the middle of this front part of the eye, you can see an opening. Now, you have a similar opening, but it's not the same shape. What is that opening that you see in this front half of the eye?
It's like right here.
It's your pupil. Now, the difference, of course, is that in you, your pupil is shaped how?
Circle.
Like a circle. But in this cow's eye, the pupil is oval. Everyone see that opening called the pupil? So your pupil is not a structure, it's a hole through what part of the eye? Can you tell from your diagram? Through the iris. Now the iris is the part of the eye that you certainly are familiar with, because that's the colored part. In humans, that's usually brown or blue or green, and a very small percentage of people have different eye colors than those three. All right? Everyone recognize the pupil and the iris. Now, we're looking at the back side of the iris, and so it appears to be black. But if you were looking at the front side of it through the cornea, then it would be, in a cow, it's brown.
So like the eye color. And then this.
So the iris surrounds the pupil.
Okay. That kind of makes sense.
And secondly, it's oval instead of circular.
Iris. Pupils that thing.
Now the back half of the eye.
So it's around the pupil.
If you will come and look at this specimen, you see that the back half of the eye looks like the white of a raw egg. It's gel-like instead of being a liquid. See, I can turn it upside down and it doesn't flow out. Now that gel-like material labeled on your diagram completely fills the posterior chamber of the eye, and it's called the vitreous body or vitreous humor. I don't know which term your lab manual is currently using.
The vitreous body.
Humor.
Vitreous humor. Oh,
And stuck in the middle of the vitreous humor, I'm
this be the
going to pull it out
iris?
now, watch,
surrounding the pupil. But I mean, it's just kind of everywhere now.
is this nearly spherical
He
structure
said it looks black, but it's supposed to be brown.
that I'm holding up.
Would this be the iris?
You've got one in your pan. It almost looks like a marble, but it's not perfectly spherical.
Okay, so
What
this is the
that?
iris. That's not the pupil.
Is it the lens?
That's the lens of the eye.
So I figured it out.
Now I want you to pick up that lens and I want you to squeeze it as hard as you can. And don't worry that it's going to rupture or something, because it won't.
It's like a bouncy ball.
It's very, very tough.
Like a marble.
Now, once again, what's wrong with this lens compared to your lens? Foggy. It's cloudy, foggy, whatever. And the animal would not be able to see. Now, does the lens of humans sometimes get cloudy? And what do we call that condition? Cataracts. And what's the treatment for cataracts? Remove this lens and put in, and I guess I'll call it an artificial one made of glass. Now, I want you to think about that in the context of this eyeball that you're studying. You know, you don't want Joe Blow doing that surgery on you, do you?
No, probably not.
Okay, probably not.
It's called the iris.
I agree.
It's around the pupil.
This is the one.
Yeah.
Now, I'm going to remove that vitreous body from this eye. Remember, it's gel-like.
The cornea is the front of the eye.
And I'm left with
Yeah, because it should be
the
clear.
back half of the eye, which looks like it's empty, but there's another layer of tissue in the back half of the eyeball. That layer is the retina.
So,
This is the part of the eye
This is
where neurons are located that will convert light rays into images that your brain will perceive as sight or vision.
what's this?
And of course, as you might imagine, this is a very delicate part of your eye. Sometimes I'm going to fold this one. Sometimes in humans, the retina becomes detached. You'll notice I folded this one. If you'll look at this, you'll see that a person whose retina detached like this would see half of their normal field of vision with that eye. And it's very critical that that be repaired quickly or it will become a permanent condition.
How do you repair it?
Surgically. But how they reattach it, I am not positive of that.
How do people go blind? Like, they can see that.
well, I'm sure there's a lot of things.
Sometimes retinal detachment results in blindness, yes. That's not the only one. Now, let's see, I think there's two more layers that you're responsible for. The outer layer of the eye is not what I just showed you, but I showed you the inner layer, the retina. The choroid is not the outer layer, but on this specimen, the choroid is a dark gray color. And what's that layer called? Look at your diagram. It's real tough.
The sclera.
It's called the sclera, S-C-L-E-R-A. So there's 3 layers to the eyeball that you have to know. Sclera on the outside, choroid in the middle, and retina is the innermost layer. One last part that I'm asking you to know, and Mrs. Hughes will too, although it's not, I understand it's not on your sheet. I wrote it up here on the board. It's called the tapetum lucidum. The reason it's not on your sheet is because it's not present in human eyes. But it is present in this cow's eye. And it would also be present in the eyes of a cat or a deer or a rabbit. And it's this iridescent blue region, that's the tapetum lucidum. Now what ability would that give these animals to have a tapetum lucidum? You don't have it.
See it now.
Reflect light multiple
It'll
times.
reflect light, and that's why if you ever have shown a light in the eyes of one of those animals, maybe a deer, maybe a rabbit, or a cat, it reflects light back to you. And you know, our term is, looks like the eyes are glowing.
Yeah.
They're not glowing, they're simply reflecting the light of your flashlight or whatever light you're shining in their eyes. That doesn't happen with you. Why? Because you don't have a tapetum lucidum.
How does our vision differ?
I beg your pardon?
How does our vision differ because we lack that?
How does what differ?
How does our vision differ because we?
Oh, they can see better at night than we can. In dim light sources, they can see. For example, the deer are feeding at night often, or the cows grazing at night, or the cat, you know, maybe it's your cat prowling around at night. They're not just groping in the dark like you do, you know.